So here we've got a curve which is in a parametric form. It's x equals 5t squared minus t and y equals 3t. And our parameter t is for all real numbers. What we want to do here is to find three examples of a Cartesian equation. Number one is a standard polynomial. Number two is an equation in terms of x. And the third one is an equation in terms of y. So how do we go about this with the three different formats? Well, first one, we could get one in terms of x and the polynomial. These two will come together. So you'll see why when I have a go in a moment. So what I would do here, I've got 5t squared minus t. To isolate the t from there, it's a bit awkward because I've got a quadratic going on here. So what I'm going to do first of all is isolate the t from the y and substitute it into the x. So here's how that goes. So for 1 and for 2, let's do those first. So y equals 3t, let's bring that down. Now to isolate the t, t will become y over 3. So now what I can do is, when I see a t in this x term, I can plug in y over 3. So let's bring the x term down. So x equals 5t squared minus t. Now we'll use this substitution, y over 3 for t. So x equals 5 times y over 3 squared minus y over 3. And that takes care of the substitution for the t. So now let's go about simplifying this off. So now x equals 5 times y squared. And then we're going to divide that by 3 squared, which is 9. So I've got 5 over 9 y squared. And then simply y over 3. So that's an equation already taken care of in terms of x. So this is part 2 already answered. So that's all done. So we can tick that off. Now we can turn this into a standard polynomial from here. So if I multiply both sides by 9, let's take care of that. So let's just draw a line under it, but continue the work. So let's just do this. So multiply both sides by 9. So then I'll have 9x. That equals 5y squared, because the 9 will cancel out from there. Multiply by 9 here. Multiply this by 9, I'll have minus 3y. Okay, so all that remains now is to bring everything onto one side. So I'm going to bring everything over to this side. So if I do that, I'll have 0 equals 5y squared minus 3y minus 9. So that's the polynomial format taken care of here in terms of number 1. So that's number 1 done. Okay, so now we want to get this in terms of y. So let's bring this up to the top, what we've got so far. So taking care of 3. So we've got 5y squared minus 3y minus 9x equals 0. Now we could get this in terms of y by introducing the quadratic formula. So to do that, we'd have a equals 5, b equals minus 3, and c equals minus 9x. So include the variable there for x. So quadratic formula. So here y would equal minus b plus or minus square root b squared minus 4ac all over 2a. And that would take care of that in terms of substitution. So let's go for that. So let's put these values into here. So y equals minus b, so minus 3, that gives me positive 3, plus or minus b squared, minus 3 squared gives me 9, so square that, I've got 9, minus 4 times a, and my c is minus 9x. And then divide that by 2a, so divide that by 10. So let's just simplify that off a little bit now. So we can deal with the discriminant here. 9 minus 4 times 5 times minus 9. 5 fours are 20 times 9 is 180. So we can put that as that. So 3 plus or minus square root of 9 plus 180x over 10. So that would be that. Now I feel we can do more here, because we could take a 9 out of these and then maybe get a 3 out by taking the square root of 9. So y equals 3 plus or minus square root of 9 times 1 plus 20x, and that's all over 10. So now by the product, this is a product inside, I can take the square root of 9 out and bring a 3 to the front. So then I've got y equals 3 plus or minus 3 times 1 plus 20x all over 10. So that's our result there for, in terms of y, that's what we would get. So we'd have the plus and the minus version for that. So that there is number 3 all done as well. Okay.